All right, here's an example similar to problem 5.4.33 on your homework. The problem says evaluate the integral. Right, pretty standard thing to do at this point in the semester. Evaluate the integral. And then it gives you an integral from 2 to 5 of x to the pi minus 1 dx. Right, so an integral, we can think of that as an antiderivative, right? So if I'm looking at this x to the pi minus 1, if I took a derivative, I always subtract 1 from the power, right? That's how we take derivatives using the power rule. We multiply the power in front and we subtract 1. Well, now that I'm taking an antiderivative, right, I'm going to add 1 to the power and then divide in front, right? So instead of multiplying in front, I'm dividing, and instead of subtracting a power, I'm adding 1, right? So I'm going to add 1 to the power. So it's going to become x to the pi minus 1 plus 1, but those are going to cancel, so it's just x to the pi. And now I'm going to divide out by the power in front, so that's 1 over pi, right? And then I'm going to evaluate this at my endpoints from 2 to 5. All right, so I evaluate that at 5, and I get 5 to the pi over pi. And I evaluate it at 2, and I get 2 to the pi over pi. Now, if you want to simplify, they have a common denominator, so you can rewrite that as 5 to the pi minus 2 to the pi all over pi. And that is how you do it. Now, if you wanted to check if this was your correct antiderivative, right, what you do is you take the derivative of it, right, and you check to see if that lines up with your integrand. So if I take the derivative of 1 over pi, x to the pi, right, so I multiply the exponent down, so I'm going to get pi over pi up front, and then I subtract 1 from the exponent. So the pi's cancel, and I'm left with x to the pi minus 1. So that's one way of checking, just to make sure that you did take, your antiderivative correctly. Just check that this lines up with your integrand. And that's how you do it.